A very warm welcome and good morning to everyone. Before we begin, I'm going to do a quick sound check. If you're able to hear me well, please give us your feedback in the questions tab. If it's problematic, if it's fine, a small thumbs up would be good. Great. So it looks like we can hear you guys can hear me fine. Thank you for joining us today. My name is Saurabh Kumar, and I'm on the marketing team here at H2O.ai. I'd love to start off today by introducing our speaker. Erin LeDell is the Chief Machine Learning Scientist at H2O.ai, the company that produces open source machine learning platform H2O. Erin received her Ph.D. in Biostatistics with a designated emphasis in Computational Science and Engineering from UC Berkeley. Before joining H2O.ai, she was a principal data scientist at Wise.io and Marvin Mobile Security and was the founder of DataScientific, Inc. Before I hand it over to Erin, I'd like to share a few quick webinar logistics. Please feel free to send us your questions throughout the session via the questions tab in your console. Erin will answer questions as and when we have time during the webinar and also towards the end of the webinar. The webinar is being recorded. A copy of the webinar and slides will be available after the presentation is over. Without further ado, I'd now like to hand it over to Erin.
All right. Thanks, SK. Welcome to the webinar on Scalable Automatic Machine Learning in H2O. All right, let's get started. So the agenda for today is first I'm going to give kind of a general overview about what the field of automatic machine learning or AutoML is. And then we'll kind of narrow into what H2O has done in this space. So we have basically software called H2O Auto ML, which is part of H2O. And we'll talk about what we have in there. And then we'll give you some pro tips on how to use AutoML. It's, by the name, you might understand it's pretty automatic, but there's also things that you can do to tweak the AutoML run as well. So we'll tell you how to tweak it best for your data set, and then we'll move to a hands-on tutorial. So that will be, code will be available in R, Python, and I will show how to use our Flow GUI. And then we'll leave a few minutes at the end, maybe 10 minutes or so for questions. So if you have questions, feel free to enter them into the system, and we will see those over here, and we'll try to pick some of those at the end. And also, while I'm doing the demo, we might have some time while we're waiting for the AutoML to run to answer some questions. All right, so what is automatic machine learning? So basically, you can kind of divide up AutoML into kind of three main pieces. So one aspect of this is data preparation. So, you know, a lot of the times you have to do some work to get your data into a format which is understandable by machine learning algorithms. So that's one aspect. And then in order for the algorithms to use the data, there's often a few things that you might need to do. For example, if you have categorical variables, some algorithms require you to do a one-hot encoding or other different types of encodings. If you have missing data, that's one thing that needs to be dealt with, and various other things. So we'll go into a little bit more detail about that in a minute. And then sort of the bulk of what automatic machine learning consists of is basically creating a large number of models and exploring your hyperparameter space to find the best model from that selection. Or if you're interested in ensembling those models together, that's another aspect. So you, instead of just choosing one best model, you can take all the models or some subset of the models and create a stronger ensemble of those. And so that's all part of what we'll be talking about today. So just to get a little bit more specific, so data pre-processing, I mentioned imputation is the filling in of missing values if you have those. One-hot encoding, some algorithms require some amount of standardization like GLM or things like that. So some other things that you can do in automatic machine learning is you could do feature selection or feature extraction. That's just a way of either reducing or expanding your feature set. And then there's another type of thing called, well, there's a couple different things called count or label or target encoding, or different types of encoding. of categorical features. So for example, if you have a very high cardinality categorical, meaning there's a lot of different levels. So let's say maybe one of your columns is zip code, and in the United States, maybe there's, don't know, maybe something like 50,000 zip codes or something like that. So that's there's a lot of levels in that one single categorical. So there's different things that you can do there. Let's see, so that's all sort of in the field of data preprocessing. And then for model generation, there's a number of different ways that you can generate a large set of models. So one thing is you can define some grid search. So Cartesian grid search is where you define a very dense grid and you try all the models in that grid. And a random grid search is where sort of you do the same thing, except for you sample from that grid search, you get more of a random selection of models. There's another field called Bayesian hyperparameter optimization, which is a little different, where instead of sort of a brute force or random approach, you start with one model and you use basically another model that is smart at telling you which set of parameters to try next. So you train a model, you give the results to this other model, it will suggest a new set of parameters, then you do that training, send the results back, and it's sort of this sequential approach where you get, sometimes closer and closer to the best model, and that's one thing. So, and then the other thing within models, you can do some tuning of. So when you have a model that has some sort of iterative learning component, let's say GBM, you're training more trees over time. One thing you can do is what's called early stopping, where you say, we're going to train a GBM with up to, let's say, 20,000 trees, but at some point, you're going to start to overfit. So you use a separate validation set to make sure that you don't overfit. So it's just slightly different from just a regular grid search, but it's the same concept essentially. So then the last thing, so ensembles, there's different types of ensembles. The simplest type of ensemble would be to average models together, which is what you have in a random forest, for example. But the type of ensembles we'll talk about today is stacking or superlearning. Those are sort of two words for the same thing. That's basically you learn the best combination of the models using machine learning. So it's a sort of meta learning on top of the models that you already have. And then there's another type of ensemble called ensemble selection, which we won't really talk about, but just there for good measure. So that's kind of an overview of different aspects of the auto machine learning space. All right, so let's talk about what do we have in H2O for AutoML. So first of all, if you're not familiar with H2O, just one slide on that is just H2O is an open source distributed, meaning it's multi-core and can be multi-nodes on multiple machines. So let's say you have an Amazon or cluster on Amazon or something like that with 30 nodes. So distributed implementations of sort of what we consider to be the cutting edge machine learning algorithms, or like the popular ones that tend to work well, like GBMs, random forests, things like that. And the algorithms are written in Java, but most data scientists are not Java programmers, so we make APIs available in R, Python, and Scala. And of course, you can also use Java. And if you don't know how to program, or you just want to take a break someday, you can just use the web GUI as well, and everything. Essentially, in terms of modeling, you can do within the web GUI as well. And so one of the sort of features of H2O is that you're writing code in R, Python, so like a interpretable language, which is easy to prototype in, but you actually are training these models in Java underneath. And one of the things that you get in H2O is you can get deployable models that are highly efficient at making predictions. So we export the model as pure Java code, and then you can put that in your production application. And so a lot of people just use H2O on their laptop and never sort of touch the distributed computing systems, but that is what it was designed for. So, you know, if you have Hadoop, a Hadoop cluster, Spark cluster, or any other type of cluster, really, you can use H2O on that as well. All right, so here's the same slide that we were showing earlier, but just with some highlights of what we have currently in H2O AutoML. So all the H2O algorithms automatically handle things like missing data or one-hot encoding if it's necessary. Our tree-based algorithms don't actually require that, so we have you know, a special way of handling categorical variables in trees. So and then standardization. Right now, I have grayed out the count, label, and target encoding. However, right now we're working on you know, adding target encoding to base H2O. So you might see that in AutoML in the future, and that's one of the things that helps quite a bit when you're trying to get performance and you've already maxed out all the modeling routes. So that's pretty exciting new feature to be added soon. So and in terms of model generation, the approach that we have right now is that we, so sort of working backwards, the ensembles that we like to use the most at H2O are called stacked ensembles or super learning. And so one thing about that type of ensemble is that it does really well with sort of a diverse selection of strong models. So one way to get a diverse selection of models is to randomly generate them. So that's kind of working backwards why we chose to do a large random grid search over all the different algorithms that we have, and then sort of collect all those sort of random models. And some of them will be bad, some of them will be very good. But when you ensemble them together, the super learner or stacked ensemble knows which ones are bad and kind of ignores those and learns how to best combine them. And then also for each of the individual models, especially in cases like the GBM, we automatically tune those with a validation set so that you're not overfitting. All right. Okay, so I kind of highlighted this in the previous slide, but basically this is just sort of re-emphasize our approach. And we might expand upon this, like maybe we would add some Bayesian hyperparameter optimization in the future. But right now, this is what we already have in H2O and what we use to create it. So, so yeah, just to re-emphasize. So stacked ensembles perform particularly well if they're based on individually strong learners. So by that, that's not very well defined, but basically it just means you're using things like GBMs and random forest and deep neural nets versus like a single decision tree. So a decision tree would be a weak model, and so we want to kind of start out with, you know, decent models to start with, and then we want to kind of grab a diverse selection of those so that they, you know, make uncorrelated errors. It's sort of the statistical term for what we're saying when we say diverse selection of models. And then stacking, I've mentioned this already, but the term that we use is a meta-learning algorithm. So that can actually be any machine learning algorithm or any supervised machine learning algorithm. And so it learns what the best combination is. And so, yeah, so in practice, we find that there's good results just using a GLM with a non-negative constraint on the weights, but you can use GBMs, you can use basically anything you want. Just want to make sure that you don't just choose one thing and just stick with that. You might want to try a bunch of different things. And in the current release of H2O, you can try different meta learners and fully specify a GBM with this depth, et cetera, et cetera. And in the next release of H2O, we'll actually allow you to do like a proper grid search on the meta learner. So that will save you some time coding that out. Okay, so just an overview. So we do the basic pre-processing, which we already get for free with all the H2O algorithms. And the ones that we have in AutoML right now, so we have, well, I don't have them all listed on this slide, but GBMs, random forests, we do extremely randomized tree forests. So that's sort of a tweak on random forests that's even more random, essentially. And then deep neural networks, GLMs, and then we have chosen the hyperparameter spaces for each of those grids. So that's sort of based on our own internal expert knowledge of what we think is appropriate, and also benchmarking on some data sets as well. So, and that's something that will possibly evolve over time, you know, to get better. So as we learn more from the system. So, all right, and then at the end we have 2 stacked ensembles that we train. So one just uses all the models that you've trained and stacked in the AutoML process. So that's typically going to end up being the best model. But then if you let it run for a long time, or let's say you have hundreds or thousands of models, you might not really want, if you're going to production, you might not want to use a stacked ensemble with 1,000 models because it takes longer to make predictions. So then we have also trained what we call best of family, where we take the best GBM, the best deep neural net, the best GLM, best random forest, best extremely randomized forest. So 5 models, and then so it's basically just a 5 model ensemble. And that actually does pretty well compared to the whole one. Usually not as well, but pretty much the same. And then what we return is this leaderboard of the models. All right, so here's just the screenshot of what this would look like in our Flow GUI. So, and I'll show you how to do this when we do the tutorial. But basically, if you're using, let's see, I think the nightly version has another feature on here, which is you can specify which algorithms to exclude. So, but if you're using the latest stable release, this is what it would look like. So you just select the training frame, and once that pops up, you'll select the response column, and then you can specify how long you want it to run or for how many models, and then you just click build. So this is what it would look like in R. So you just load the H2O library, start the H2O cluster, load some training set, and then tell AutoML which column is the thing that you want to predict, so the response column, and then you just specify how long or how many models you want it to run for, and then it runs, and then it returns this leaderboard as a data frame. And so the same idea in Python. So just one more line of code where in the Pythonic sense, we like to create an object of class H2O AutoML with this the things that have to do with that, like max runtime seconds, and then there's a train method afterwards that actually runs the AutoML process, and then it also will return a leaderboard as a data frame. Okay, so then what does this look like when you get it back? So you get some sort of data frame with all the models that have been trained, and then they'll be ranked by their performance. So for binary classification, right now we just have a column for AUC and log loss. I think probably at some point we would add all the relevant metrics, but I think for now we just added those because those are pretty much what people would want to use. And then the scores are actually by default the cross-validated scores. So when you run AutoML, it will actually do 5-fold cross-validation by default on all of the models. And so these are cross-validated AUC scores. So you see in this example, this is the example from the user guide on our docs website. So typically this is what it would look like. The stacked ensembles are generally at the top, followed by the GBMs, and then it's not always this way. If you have very non-standard data, you might get things like GLMs at the top or deep neural nets. It just depends on your data. Okay, so we're going to just go over a few pro tips. So you pretty much don't need to know anything. You can just press a button and go, but this will help you to understand a little bit better what's going on. So before you press the big red button, these are some things that you might want to think about. So one thing that we have is, so we have training frame, validation frame, and then we have a third frame that you could pass along that we call leaderboard frame. And you might be tempted to use that, but unless you really need to use that, I wouldn't recommend it because it means essentially that you're using some of your data just to score the leaderboard. And when data is precious, we don't want to sort of waste data doing something like that. So so we already are doing cross-validation, so we might as well just use cross-validation metrics to rank the models on the leaderboard. However, there's a lot of cases where you might want to score on a particular frame, maybe, who knows? So that's there for you to use. So so really all you have to do is provide the training frame, and even though there is a validation frame argument, you don't have to use it. So if you don't specify a validation frame, we will just make one for you. So we'll take 20% of your training frame and chop that off, and that's for basically tuning the GBMs, but also the other algorithms. And it also, if you'll notice in the interface for AutoML, there's some early stopping parameters, which I'll talk a little bit about later. And we also use that for early stopping of the grid searches and the AutoML run itself. So anyway, but maybe you don't want to use 20%, maybe you only want to use 10%. Well, then, you can just make your own validation frame and pass that along, and then we won't touch your training frame. So usually if I'm like strapped for data, I probably use like a 10% validation frame. Okay, so here's a new argument that we just added in 3.18, which came out, I think, last week. So a couple of users had asked for this. So they said, I have like text data or wide data and sparse data, and they didn't want to use the tree-based algorithms. They knew that they wanted like only GLMs or only deep neural nets or something like that. So before we were just, and by default, we'll train all those algorithms because in general, you don't necessarily know what's going to work well unless you have a very specific type of data. But if you want, you can turn things off. And if you think that, you hate deep neural nets and GLMs, you don't like them, you can turn those off and, just get GBMs and random forests. So that's a new option that gives a little bit more control to the user. All right, so how do you stop this thing? So, you could, the default is that it will stop after 1 hour if you don't change anything. So, so that's kind of a built-in like shut off valve, I guess. So if you change the max runtime seconds to something way higher, then, we'll run for however long, you ask it to. But one thing that you might want to think about is if you're trying to be reproducible with your workflow, running based on time is maybe not the best thing because you maybe run it once and you have a lot of stuff running on your machine, and so it can only do so much. And then the second time, maybe you don't have as much running on your machine, so it's basically resource driven. So if you want to ensure that you get the same exact models each time, then you want to set a seed and use the max models. And then if you need to have it trained for more than an hour, you would still want to up the max runtime seconds. Otherwise, it will still stop after 1 hour. So, all right. And then in terms of memory, so when we're talking about training, 1,000 models, you might have to start thinking about how much memory that you have. So just as a reminder, all H2O models are stored in memory. So the H2O cluster memory is basically this shared Java process running on your cluster or on your laptop, and everything must fit in there. So usually the big amount of space used by that memory is your training data. But if you start to train thousands of, let's say GBMs, a lot of trees or something like that, then it could start to fill up. So and we might add something in the future to maybe like clear out bad models as you go along so that you don't waste space storing them, but that's sort of just in the future. So for now, just make sure that you have enough memory to run as many models as you want. All right, so after you've pressed the red button and taken a coffee break or whatever, worked on some things, read some articles, gone on Twitter, whatever it is that you now can do now that you have this tool to automate your job, basically. Then, all right, so let's say the model is done. And let's say you look at your results and you say, you know, I thought there would be more models. What happened here? That might have something to do with our early stopping settings. So if you, you know, asked for a lot of models and it stopped early, then that probably is saying you're running up against our early stopping settings. So by default, we also try to not train too many models if there's not additional performance. So we have some parameters built in to prevent that, but you can turn that off, or you can just make it less restrictive. So if you, well, to turn it off, you would set stopping rounds equals to 0. But if you still want the early stopping built in, but you don't want it to be as eager, then you can increase the number of stopping rounds and or decrease the value of stopping tolerance. And if you want more information about that, these are the same terms that we use in all the individual H2O algorithms as well. So stopping rounds, stopping tolerance, and stopping metric. So you can read more about that in the documentation. All right, so one sort of workflow process might be that you don't know that you want to train 1,000 models in advance. Maybe you just want to train 10 or 20 or 30 or 100 even. And so you run an AutoML job, and then it trains a bunch of models, and then you might say, okay, I'm happy with the performance, but maybe I want it to run for longer and see if it can get better models. So then in order to do that, you just essentially run the same code that you have a second time, and just make sure that you use the project name. So that's an argument that's, you don't have to set that by default, but if you, and it will actually automatically fill it in, but with something based on the name of the training set and that type of thing. But basically to add more models to an existing AutoML run or project, you just add to the project name. This is kind of similar to when you use the grid search in H2O and you want to add more models to a grid, an existing grid, you just make sure to specify the same grid ID. And then this is just a warning. If you set the same seed twice, it will actually just produce the same exact thing, which I realized a couple weeks ago as I was using it. And so if you want to get different models, which is most likely what you want to do, either change the seed or unset the seed. And then how do you save the models? Well, all of the models in AutoML are just regular H2O models. So on the leaderboard, you can see the model IDs. And so if you want to save a single model or even save an ensemble, you just you know, grab the ID for that model, and then you use the H2O.save model function. And then I mentioned this kind of before, but if you want to, you might not always want to take the leader model, because if the leader model is, you know, the all models stacked ensemble and it has 1,000 models in it, maybe you want to take the second best model or the, you know, best of family stacked ensemble if you're going to go to production. But if, you know, prediction time is not an issue to you, then you might as well just use the best one, which would be the all models. Okay, so let's jump over to the tutorial. So here's a link where you can find the code. And so this is a tutorial that I gave at H2O World 2017 in December, so a couple months ago. So we'll just be going over the same code there, and I'll wait a minute for anyone to write down that link if they're interested. And so if we click on this, actually I'm not going to click on it because I'm going to go over here, and I already have it up here. All right, so this is, let's do that. Okay, so this is just in H2O on GitHub. We have an H2O-tutorials repository, and there's a bunch of stuff in there, but this is inside the H2O World 2017 AutoML directory. And this is a longer tutorial than we won't go over every single thing in here. But what you'll see in here is sort of a description of the task. So the first two scripts in Python would be binary classification demo, and this will go over all the individual things that you can do. And then the second would be a regression tutorial. And this, we highlight some different aspects and different ways of using AutoML in the second tutorial. But we're going to start out with Flow. So we're going to still use this product backorders dataset. So the goal in this dataset is to predict whether or not a product will be put on backorder status. And so there's things that are related to that, such as the current inventory, transit time, demand forecast, and prior sales. So we'll hop over to Flow, but let me just teach you real quick how to use Flow in case you've never seen it. So one thing would be, where do you get Flow? So let's go to h2o.ai/download. And then you'll see just a general download page with all of our different projects. Every night we release a new version of H2O, which is from master, and that's here, but typically you want to just use the latest stable release. So you click on that, and you can see the version number here, 3.18.02. So, and then we have tabs for each thing. In R and Python, generally, you might just want to use the typical way of installing packages. So pip install H2O or install packages H2O in R. But let me just show you how to, basically for Flow, you just have to download H2O as a zip file. So you click on the download button, and then it'll, if you're on a Mac, it'll automatically unzip that for you and put it in a folder. And then you just type in this one command to launch the H2O cluster, which is a Java process. So let's see, we'll bring that up. So I'm gonna actually kill the one that's there. So, and then let me just show you what's in this folder. So there's a jar file, java-jar, H2O jar. That's actually just gonna start the process. And this is all the sort of technical thing that you'll have to see when you use Flow, but now we go over to Flow, which is always at localhost 54321 by default, unless you're running it on a server or a different port. Okay, so this doesn't have anything in it. So if we say get frames, it'll say there's nothing here. Get models, no models. Okay, so totally clean session. So you can either use import files or upload file, but I like to use upload file because I don't like to type if I'm using Flow. I just like to click around. All right, so I'm going to find this product backorders data set. And I'm going to upload that to H2O. And when I say upload, I don't mean to the cloud necessarily. I mean, I'm uploading it to the H2O cluster, which is a local process that you own on your own machine, running all your own software. So sometimes people think that H2O is some sort of service or thing on the cloud that you interact with, and that we get your data and we store it and we store your models, but that's not actually how it works. So you can set H2O up on the cloud yourself and interact with it there on Amazon or Google or wherever. But really, you're just running it as a local thing on your machine. Okay, so this is kind of what the data set looks like. Let's click parse to actually get the data into H2O, and then we'll look at it here. So here's a bunch of columns. So we've actually got, let's see, 23 columns, 19,000 rows. And this is all compressed in memory. So H2O is very efficient about memory when it can be. So let's just take a look. So we've got columns here. So I'm noticing this thing here. So SKU, that's an ID for a product. So when we train a model, we never like to have things like IDs in there because they're usually either leaking data or they're completely non-predictive. So when we train the model, we'll exclude that. But the rest of the data here is is fine. So went on back order is the thing that we're going to predict. So let's go up here. Scroll down to run AutoML. As of like 2 days ago or 1 day ago, we moved this run AutoML up to the top. So you'll see it up to the top in the future. But here we go. All right, so we are going to grab our product back orders data set. And the thing we're predicting is went on back order. And then we wanted to ignore the SKU column. And let's see, so basically we don't have to change anything else, but let's just train this for 10 models and see how that goes. So notice that I'll put in the max models here, but since I'm fairly confident that this will run in less than 3,600 seconds, which is 1 hour, then I don't need to change that. If I thought 10 models would take more than an hour, I would have to increase this so that it could finish, but you don't have to set a seed, but let's just do that for fun. Okay, so you'll see here it actually prints out like what it's working on at any given time. So it first builds a default random forest. Now it's working on the extremely randomized trees random forest. It's doing a quick GLM hyperparameter search. And there are currently 5 hard-coded GBMs that we find to be good. So, and those are given to us by some of our data scientists here. And they're just basically 5 GBMs with specific parameter settings that we think typically do well. And those are actually run outside of the random grid search, but they'll run before that. So GBM3, and keep in mind what this is doing is it's doing a 5-fold cross-validation on basically 20,000 rows. So it's training six models for each of those things that you see there. So GBM5 is actually training a total of 6 GBMs, 5 for the cross-validation loop, and then 1 for just the model at the end with the whole data set. And one thing else to note is that I'm running this on a MacBook right now. So, so I have 8 cores on my MacBook, and it's using all of those cores. And the fan is only slightly making noise right now. So, all right, okay. So sometimes the progress bars are a little jumpy, so it thinks it's not done when it is, but here we go. So it's basically done. So if I click view, this is the Flow version of the leaderboard. So, all right, so actually I might have clicked on it too early, I'm not sure, because I'm not seeing the best of family stacked ensemble here, but that's okay. So if we look at the performance, so we've got, this is obviously a pretty easy problem. We've got an AUC of 0.947. And in this case, the stacked ensemble is slightly beating the GBM. So, you know, whether or not that third decimal point makes a difference to you is sort of a, you know, a business question. If you're using Kaggle, absolutely, you'll want to use, you know, that third decimal point, and actually probably more like the 5th decimal point makes a big difference. So you can click on each of the individual models here. These are links. And then you'll also see below, we haven't worked this into the R and Python clients yet, but it's essentially a log of what's going on in the AutoML process. And it's probably too verbose, so we'll maybe clean it up a little bit. But so let me click on the stacked ensemble. So you'll just see general stuff that you typically see in Flow. And let's see, one thing that's a little bit interesting with stacked ensembles is to click on the meta learner, because if you click on the meta learner and you scroll down to the variable importance, let's make that a little bit bigger. What it will do is it'll actually show you some interesting information. So, so if you think about what the meta learner is doing, it's a model that takes as input the predictions from the individual models. And so the features are actually, representing different models. So you can see how kind of important, in this case, the meta learner by default is a GLM. So these are just sort of actually standardized coefficient magnitudes. So what we see here is the highest coefficient was the extremely randomized tree model, and then the GBM, et cetera. And so you can kind of see, there's one GBM down here that was, had a terrible set of hyperparameters selected randomly, probably. And the deep learning model is also not doing well here. So yeah, that's just kind of how you can, this doesn't necessarily give you any actionable information. It's just interesting to kind of see how the meta learner is prioritizing the different models inside. Okay, so that's basically how we do this in Flow. So let's see. The next thing, if you go back here, we're actually going to do these two scripts now. So the AutoML in R and then Python. All right, so let me bring up Python first. So this is what we have here. So I'm going to go ahead and just click through these cells. So because we're already running an H2O instance at the default location of localhost 54321, it's not going to start up a new cluster. It's just going to connect to that one that we already started with Flow. And so one thing that you can do is you can kind of go back and forth between Flow and Python, or Flow and R, or even between Python and R, but that's not typically what we see people do unless we're debugging something. So this will print out information about our H2O cluster. So it's been up for 8 minutes. Here's the version of H2O. This release is 6 days old, and it's one node. So I'm just running this on a laptop. So one node. By default, we give it 4 gigs of memory, but you can make that however big you want, assuming you have that amount of memory on your machine. And I have 8 cores on my laptop. These are just some other things to note. So we, as I'm seeing this, I'm reminded that people have been asking about XGBoost in AutoML, and that's coming soon. So we've had XGBoost inside of H2O for maybe the last 2 or 3 releases, and this last release spent a lot of time on improving the stability of that. And so I think by 3.20, which would be the next release, I'm hoping that we'll have XGBoost fully stable and we can put it inside of AutoML, and then that will actually really be nice, because XGBoost models are typically perform the best of anything on a lot of different data sets. So if we have that and we have ensembles with all the other things, it should be even better than a regular XGBoost model. So that'll be exciting. All right. So here's how to load data. This is the import file. This little if statement just basically checks if I have this data set locally, which I don't, because I'm not running this in the Docker container that we used for H2O World. So it will go out and actually download the data set from this path. And so it right now just downloaded the data set and loaded it into H2O. Now, depending on the size of the data set and your internet speed, that could be a while, or if you have it locally, it's always best to just do that. So df.describe will just show you a little bit of information about the data set. And here's the SKU. So here's just more information than we had before in Flow, or at least that we talked about in Flow. So here's went on back order. And one thing that I'll mention, just because if you're completely new to H2O, we see people get confused about this from time to time. So if you have a binary classification data set or task, and you have your response variable encoded as 0 and 1 instead of something like yes or no. So yes or no will automatically be parsed as a categorical variable with 2 levels in H2O when you load it in. But if it's zeros and ones, H2O, unless you tell it otherwise, will just think that that's numeric data. So if you load it in, it stays numeric, and you try to train models or AutoML, what it will do is it will do a regression problem instead of a binary classification. So if you want to make sure that it's doing the right thing, then you just need to encode the response as what it should be. So if it's zeros and ones, you just do this thing here, and you can click on it in Flow as well. But basically, you just have to do this .as factor, and that's in R or Python. So you have to convert it if it's zeros and ones. So that's just a side note. But so AutoML has the same interface as all the other H2O algorithms, where we use an X to define the column names or indices of the predictors in your training set, and then Y would be just the response column as a string. And then if you want to, like, one thing I do, if I just have most of the columns as predictors and maybe want to remove 1 or 2, I would just do it like this, where I first set it to be all the columns, and then I'm just going to remove Y and the SKU. All right, so let's do this. So we're going to run this for max models seed 10, which is exactly what we just did in Flow. And we'll let that go. And what I'm going to do is, while this is running, I'm going to go over one question I think I'll have time for. So one of the questions somebody said is, how can startups enter into AutoML where resources are limited? So basically, I think the question is asking, like, if you're, let's say, a startup that doesn't have a huge data science team, or maybe even just has one single person, or maybe even just an engineer who's trying to do data science, this is like very easy to start with this as a tool to use, because basically you don't have to know really anything about tuning or training models that well. Like, you just have to kind of know the basic concepts, that there's a training data set, what a validation set is. Basically all this stuff that you could learn from a single slide deck. I have like an intro to data science slide deck, I think from H2O 2015, H2O World. So it would just define, like, what is a training set, what is a validation set, what is a test set, and some of the other terminology, like what is a response column, like what is classification versus regression, and then what metrics go along with each of those tasks that are good to use. And then if you have some like highly sophisticated, data science guy or gal at your startup, then basically AutoML can also just speed up their workflow. So I basically, like, we built this to satisfy our own needs. And so I was sick of writing. I'm a huge fan of ensemble, so I would write these very large grids and train them, and then ensemble everything together, and like have to analyze the results. And it was just like a lot of code where we could just basically put a wrapper around all of that. And then if I see something that sticks out to me, I see a GBM that I really like, maybe then I can go in and fine tune things. But this is like a great thing to run, to know like what's the benchmark, basically, is like how you have something where you get a pretty good model, and then it's up to you whether or not you want to spend more time to get a better one. All right, so we've trained that. Here's the leaderboard. Here's what it looks like. Looks very similar to what we had before. In this case, the GBM, the best GBM, is actually slightly higher than this best of family stacked ensemble. So that can happen where basically, they're not that different. So you could choose to use the GBM in this case if you wanted to. And then, so that's actually just printing the top, I think, 10 rows. If you want all of it, you have to just specify. All right. We already went over this a little bit. This is just how to explore the ensemble in R. And I'm going to spend the next 2 minutes going over the R code. So I'm going to pull that up over here and just show you exactly the same thing in R. So Shout out to the R ladies if there's any in the audience. All right, and R dudes as well. All right, and R all gendered people. All right, so here we go. Start H2O, library H2O. Let's scroll down. We've got an H2O init statement. I'm just showing you the HTML output instead of actually running the code because it's a little nicer to look at. So this is exactly the same thing. We're going to load the data. Almost all of the functions are either identically named in R and Python or something very close. So we have, again, H2O describe, shows the data. And then this is the same thing that we did, was define Y and then define X as the difference between the full set of columns and Y and the SKU. And then this is just the interface for R, Y, X training frame, max model seed. And then basically, here we go. Our leaderboard is stored here. Same thing, print the leaderboard, or if you want to print the whole leaderboard, you'll be required to use the N argument. And one last thing, this is how to save. We have two types of model formats. So one, we have binary models. So that's the easiest to use. And if you're a data scientist, you'll probably like that one better. It requires you to use the H2O cluster. So basically, in order to make predictions, the model, if you've saved it to disk, has to then be loaded back into the H2O cluster, and then you can make predictions in memory in R, Python. And then if you're actually trying to build an application around this and take it to production, and if speed is of utmost importance to you in making predictions, we have this other format called MOJOs, which stands for model optimized something, model optimized Java object, I think. Yeah, so we have POJOs, which is plain old Java object, and then MOJOs is sort of the newer one. So there's a whole section about that, how to use those on our user guide. And all right, so let's see. Let me just mention one other thing over in the regression demo, if I have a few minutes. I just want to show you how to make predictions once you have an AutoML object. So we'll just do this in R. Okay, so scroll down here. So once we have this AutoML object, we can basically the H2O predict or the standard predict function works in R, and in Python, same idea. But you can pass in an AutoML object as if it were a model, and it can make predictions. It will just use the model that's the best on the leaderboard. So that's one way to do it. Then, of course, if you want to use a different model than the leader, then you would just grab that model by the model ID and then make predictions that way. So remember, these are just regular H2O models, so it's just the same way of interacting with them. All right, and this example is kind of interesting, this regression demo, because it's basically you're predicting power plant, what is it? Power plant, let me scroll up, the hourly energy output of a power plant. And so this was written into a paper in 2014, and in the paper they got some results, and we were able to beat those results with AutoML using just 60 seconds of running AutoML. So that's pretty exciting. So if you want a new hobby of finding papers and getting better results and trying to republish them, that could be a great use case for AutoML, especially if you're in academia and you need to rack up some papers. I'm kind of joking, but also not joking. All right, so let's see. So in the next, I don't know, 5 or so minutes, we'll do a few more questions. Let's see. Here's one that says, is there a way to connect H2O to a live data store rather than manually importing a file? So remember that you have to have the data in H2O memory. So no matter what, like if you have so it depends on what you're asking by this. If you have like a live database that's constantly being updated, you still have to, we can import data from a database into H2O, but it would be taking a snapshot. So there's not a way to sort of stream in new data. But you could write code that would query the data source every second or two, and then add to your training set if you wanted to do something like that. So next question, are there any tools for interpreting stacked ensembles generated from H2O's Auto ML and like LIME? So LIME is a sort of new methods that stands for locally interpretable model explanations, and there's an R package and a Python package. And if you use the R package, it already has support for H2O models, so it's pretty easy to use. And so, a stacked ensemble is just like any black box machine learning algorithm where, so you can use any of these methods like LIME that can work on that. So I guess the answer is yes. So it says, how does the program choose which models to try in AutoML? So basically, right now, the AutoML process is not dependent on your data. So in the future, we hope it to be a little bit more dynamic, where it will look at particular aspects of your data. So like an easy one that we have a ticket open right now is like if your data is highly imbalanced, like we will automatically do some balancing of your data. And then we might look at things like sparsity, like is this a very wide sparse model? Maybe we automatically turn off some of the tree models for that. So basically, we've just come up with generic settings that we think are good for generally all models. And then since we do such a large sweep of the parameter space, if kind of good models will come out of that regardless of where you start. And then the stacked ensemble will do a good job of sort of fine tuning that and putting those together. Another question is, can I use AutoML for clustering? And right now the answer is no, but that might be something that we would do in the future. But our k-means function in H2O is pretty good, and it will automatically find the number of clusters for you if you would like it to. So that's kind of a little bit automatic already. Let's see. Could I specify different variables for different algorithms in the ensemble? In AutoML, we just use all the variables. But if you use the stacked ensemble function, you can train models, or I mean, you can ensemble models that were trained on different subsets of the features. So that's, I think, what you're asking. Let's see. Somebody's asking about how does it deal with the imbalanced data sets. I already mentioned that, but we will be sort of coming up with our own rules for deciding when to trigger that. But yeah, and probably 10% is where we would choose. So if it's less than 10% of the minority class, we would start to balance that automatically. And H2O algorithms have that already built in. So it's just a flag that we have to set, which says balance classes. And then there's some other tweaks that we have to that. Let's see. Who is this tool's target audience? Well, so I think it's like pretty much anyone can use this tool and find value in it. So I think, if you're, I mean, I use it and I'm writing these tools and I'm doing this type of, coding and machine learning all the time, and I find it to be extremely valuable. So, so I think advanced data scientists, it's good for people like that. It's good for people that don't know where to start with machine learning and just have some basics. And it's kind of good for like anyone in between. And it's just, keep in mind, it's just one tool in your toolbox. So I would, for me, my workflow is I would always at least try to use AutoML on some, data problem that I have, and then see what comes out of it, and then maybe do some more advanced stuff later, or maybe run AutoML for longer, or maybe do some more of my own feature engineering on the front end, and then feed it back into AutoML. Let's see. Okay. How is AutoML different from driverless AI? So that's a good question. So at H2O, we have another tool that's called driverless AI, which is a proprietary product that's, I don't know, we've been selling it for, I don't know, good 4 or 5 months now, maybe. And it has a very similar goal. So it's like basically automating machine learning and getting the best models that you can possibly get. So the main difference is obviously AutoML is open source, driverless AI is a product. And then you might ask, well, why would I pay for something if I can get it for free? Well, there are differences. So the main difference is that driverless AI has a very strong focus on feature engineering, so automated feature engineering, and that's basically taking like the brains of several Kaggle grandmasters that work for H2O and putting all of their like dark art of Kaggle, whatever into driverless, and so it will, for that reason alone, do better than AutoML. But the modeling techniques are similar, and there's some other aspects of driverless AI, so some other components other than the modeling. So there's automatic visualization as a whole separate module, and then there's something we call MLI, or machine learning interpretability tool, which is a whole separate thing as well. So people might buy driverless AI just for the model interpretability, for example. So if you're in a banking or regulated industry and you need interpretability, that might be a reason to buy that. So what else? Someone's asking about pre-processing. So can it handle missing values? So yes, it can. What size is the validation set, and is it a stratified split? So yes, and it's 20% of the training frame by default. Let's see. Okay, what is the criteria for what algos are run? Specifically, it seems to build way more GBMs than all other models combined. So that's true. And we allocate more time to the GBM grid search than we do to anything else, because it produces basically better models on average. So so one thing we'll probably do is when we add XGBoost, we'll add another grid of XGBoost GBMs, and then we'll have to share the time a little bit. Maybe we'll take a little bit of time out of the H2O GBM and give some to the XGBoost. And then right now it doesn't spend very much time on the deep learning component. And I think when we improve the hyperparameter grid for our deep learning, we will give more time to that. And also we might want to do a little bit of grid searching on the random forest. So it says the deep learning AutoML models only have one layer when I run them. Is this expected? No, it's not. So I think, so I was mentioning that sometimes that deep learning gets shortchanged a little bit. We don't give as much time to that. So we're gonna basically change that a little bit in the future. So I don't think, I can't remember exactly all the exact hyperparameters of our deep learning, but I think they mostly have more than one layer by default. So will the slides be available after the presentation? That sounds like a good last question. Yes, they will be available. And if you're watching this webinar, we will be emailing you with a link to that. And then we always put our slides up on our SlideShare account. So if you look for, I think at the end, well, I was going to say in my slides, there's a link to where the slides are going to be, but that's not very useful. So if you just Google SlideShare and H2O AI, you should find all of our slides there. And then if you also receive the slides online, you can see there's links at the very end that has references to where we put all of our videos, where we put all of our slides and our tutorials and all of that stuff. So, so we're gonna wrap this up, and if I didn't have a chance to answer your question, I would like to reach out to you via email this week, and we have all the questions here. So now I'm gonna pass it back to SK, who will be sharing a few closing comments.
Thank you, Erin. Before we wrap up here, I'd like to say thank you to everyone who joined us today. A special thank you to Erin again for such a wonderful presentation. If you're in the Bay Area, I'd love to invite you to join us at a few upcoming meetups and conferences, including Strata San Jose and GDC San Jose. For more information on these, please visit h2o.ai/community. Thank you again.